Hello everyone, this is first part video on past year NEET questions from the topic solid state. We'll begin with the first question. This is a question based on the molecular formula of the substance where in these type of questions, right, we'll be given what kind of sites or positions the cations will occupy and what kind of places the anions will occupy. Based on the relative count, we will be able to find the molecular formula of the substance. So in simple ionic compounds, we will be given cations and anions. Sometimes we may have multiple cations or multiple anions also. Okay, so look at this question. This is a question that has come in, by the way, 2019. A compound is formed by cation C and anion A. The compound is formed basically because of what? The cations C and anion A. The anions are forming the hexagonal close packing. Anions are forming what? They are forming the HCP structure. And the cations occupy 75% of the octahedral voids. Where the cations are positioned, they are occupying 75% of the octahedral voids. The formula of the compound is, so we need to express the formula of the compound. So if you look at it, right, first thing is what? The anions are forming the HCP. So in HCP, right, what is the number of atoms per unit cell in a HCP? Number of atoms per unit cell in a HCP will be 6. In a simple cubic it is 1. In a BCC it is 2. In a FCC it is what? 4. In a HCP it will be 6. And the number of octahedral voids in any type of lattice, right, the number of octahedral voids will be equal to the number of lattice points. Means if the number of atoms per unit cell of the HCP is 6, then what will be the number of octahedral voids? Number of octahedral voids also will be equal to what? 6. Number of tetrahedral voids means it will be double the count. It will be 2n. If n is the number of total lattice points, octahedral voids will be n. Tetrahedral void will be 2n. Okay. So if you look at the positioning of these anions are forming the HCP, means the number of anions per unit cell will be what? 6. Now when it comes to cations are not occupying all the octahedral voids. Cations are occupying what? Only 75% of the octahedral voids. Means what? If you look at what is the number of octahedral voids occupied by the cations, it will be what? Total number of octahedral voids is 6 into 75% of that means what? It will be 75 by 100. So it will be what? If you simplify, 25 3s are 25 4s are, then 2 2s are 2 3. It will be what? 9 by 2. So if you look at the cations, what is the cation count? 9 by 2. What is the anion count? 6. We have to go for the simple ratio. Means it is 9 by 2 is to 6. First of all, 3 3s are 3 2s are. So the ratio will be coming as what? 3 by 2 is to 2. We cannot write the formula as C3 by 2 A2 because always the compound formula, right, should be having the number of atoms in the whole number form. We cannot have fractions. Okay, fraction we will only represent in very specific cases where we want to express the metal deficiency defects. Like if you have a metal deficiency defect, right, in case of say for example iron oxide, we'll put it like iron 0.960 or nickel oxide, nickel 0.960 or whatever the fraction, right. So that is only used to express what? Metal deficiency defect. But otherwise when we are giving the formula means we always give the formula in terms of the whole numbers. So we cannot have 3 by 2 is to 2. We should make it as whole number. What we can do? Denominator part is what? 2, right? We'll multiply both of them by 2. So C will become what? 3 and A will become what? 2 2s are 4. So what will be the formula? C3A4. What will be the answer for this, guys? Correct answer is what? Option D. C3A4 will be the formula for this ionic substance. So to answer these questions, right, only thing is we must be careful in terms of doing the count and then the final calculation. So these two areas, if you are able to take care of it, right, these kind of questions are straightforward questions. Okay, let's look at the next question. This is the question that has come in the Odisha NEET paper 2019. So this is what I was talking about, the metal deficiency. Okay, the formula for nickel oxide with metal deficiency defect in its crystal is nickel 0.980. What is the formula for the substance? Nickel 0.980. The crystal contains nickel 2 plus and nickel 3 plus. See why this metal deficiency defect comes. If you have nickel oxide, right, everything is what? Nickel 2 plus. But if some of the nickel 2 plus are replaced by nickel 3 plus, how they will replace? For every 3 nickel 2 plus ions, only 2 nickel 3 plus ions will come. So the count of the nickel will be reduced. That is why we are having the fraction of the nickel contribution is what? 0.98. So why it is happening? Because for every 3 nickel 2 plus ions replaced, we get only what? 2 nickel 3 plus ions. Now let's come to the question. The question is the fraction of nickel existing in the nickel 2 plus ions is. So we need to find what fraction of the nickel is existing as nickel 2 plus ions. So the total, if you look at the proportion, right, so take a look at this formula, nickel 0.980 means for every 1 oxygen atom or 1 mole of oxygen atoms, we are having what? 0.98 fraction of nickel atoms. If you take in this, right, let X be the nickel which is in the form of nickel 2 plus, then what will be the nickel in the form of nickel 3 plus? 0.98 minus X, that will be the nickel in the form of nickel 3 plus. All these questions, right, they are solved by using the charge balance concept. What is the charge balance concept? So we are saying the amount of nickel 2 plus is what? X. The amount of nickel 3 plus is what? 0.98 minus X. Total charge of cations will be equal to total charge of the anion. See, we have 1 oxygen atom, right? What will be the charge of the anion? 2 units. Total charge of the cations means what will be the situation? We have X nickel 2 plus ions. Each nickel 2 plus will have how much charge? 2. So 2 into X plus nickel 3 plus, what is the charge? 3 is the charge. 3 into what is the amount of nickel 3 plus? 0.98 minus X. If we add both of it, right, it should be equal to what? The total charge on the anion, which is 2. So this charge balance method, right, is the approach that we will be using to solve questions like this. So total charge of the cations will be equal to what? The charge of the anions. Now if we simplify it, right, what it is what? 2x plus 3 into 0.98 is what? 2.94 minus 3x will come is equal to 2. So simplify if you do, then x will be coming as what? 0.94. But look at what they are asking. They are asking the fraction of nickel existing as nickel 2 plus. What is the total nickel count? Total nickel count is what? 0.98. We can say it is the fraction, or we can say this is the moles, whatever it is. This is the total amount of nickel. In that, what is the amount of nickel 2 plus? Nickel 2 plus amount is coming as what? 0.94. So we are looking for the fraction. So what is the fraction of nickel 2 plus? Means what? The amount of nickel 2 plus by total amount. 0.94 by 0.98. And this will be coming somewhere close to, because 0.94 by 1 means what? 0.94. So we are dividing by something less than 1, means this will be definitely slightly more than 0.94, and we can even look at the options and then probably take a intelligent guess in terms of what can be the answer. So it will be slightly more than 0.94, and what will be the answer for this, guys? 0.96. Okay, so if you are very particular, you can even continue with the calculation and get the final answer. But this is where, right, we have to save some time, because there is no reward for getting the answer up to the last decimal place. You look at the other options, right? What are the other options? 0.04, 0.5, 0.3. That quite different in terms of what it is. Okay, so this kind of an flexibility, right, we will have when it comes to competitive examinations. While when you are preparing for a board exam or things like that, right, you might not have this luxury. You will have to still work out the steps and get the answer. But here, possibly by the way the option is coming to us, we will be able to choose what is the most suitable answer. Okay, so we'll go to the next question, guys. Look at this question. This is a question that has come in the NEET 2018 paper. This is a question based on the density formula. So if there is one formula that is important in this chapter, it is the density formula, guys. What is the density formula? Density rho is equal to what? Z into the atomic mass m by Avogadro number into a cube. What is a? A is the edge length. What is a? A is the edge length of the cubic unit cell. Look at this. Iron exhibits BCC. BCC structure means what? Body centered cubic structure at the room temperature. At 900 degrees centigrade, it transforms into FCC structure. Means when the temperature is changing to 900, right, it is transforming into what? FCC kind of a structure. The ratio of density of iron at room temperature to that of at 900 degrees. So we need to find the ratio. We need to find the ratio of the densities. Assuming that the molar mass and atomic radius of iron remains constant. Means they are saying that assume the molar mass and atomic radius of iron does not change with temperature. So what happens here? I mean, when the structure is changing from BCC to FCC, the density formula, two things will change. Because Z is what? Number of atoms per unit cell. That will be changing. The atomic mass of iron will not change and Avogadro number also will not change. But what will be the other thing that will change? A will change. A is what? Edge length. So whenever we have a metallic lattice, right, we have a relation between the radius of the metal atoms and the edge length. So we have a relation between radius of the metal atom and the edge length. What is the relation? If it's a BCC, right, the total body diagonal, which is root 3A, will be equal to 4R. Means A will be equal to what? 4R by root 3. A will be equal to what? 4R by root 3. That is in case of what? BCC arrangement. If it is a FCC, right, the phase diagonal root 2A will be equal to 4R. Means A will be equal to what? 2 root 2R. A will be equal to what? 2 root 2R. So as we change the structure from BCC to FCC, the edge length value also will change, because edge length is dependent upon what? It will be related to the radius of the iron atoms. Now density formula is what? As we are discussing, what is the density formula? Z into atomic mass by Avogadro number into A cube. That is at room temperature means it is for the BCC formula. At 900 means it is the FCC formula. Okay. So here, if you see, right, as we have discussed before, M and Avogadro number, they will not change. They will be as it is. Okay. Now Z value for the BCC is what? 2. Z value for the FCC is what? 4. And the A cube is in the denominator. Means the A cube FCC will come to the numerator and A cube BCC will come to the denominator. So if you just simplify it, right, numerator Z of BCC is what? 2 divided by Z of FCC is what? 4. The 2 by 4 is as it is. And the A cube of the FCC will go to the numerator. Look at this numerator, what we have? 2 root 2R whole cube. Divide by A cube of the BCC. What is A cube of BCC? 4R by root 3. That will come to the denominator. So A of the FCC divided by A of the BCC whole cube we are putting. Okay. Now if you try and look at this, right, R and R will be cancelled. Okay. And the root 3 will come to the numerator. So essentially what we will be having is root 3 by root 2 the whole cube. Outside we have 2 by 4, which is 1 by 2. Okay. Means root 3 whole cube means what? 3 root 3. What is this? 3 root 3. And root 2 whole cube means what? 2 root 2. So 2 into 2 root 2 will be what? 4 root 2. So finally what is the ratio? 3 root 3 divided by 4 root 2. So the ratio of the densities, right? So here to solve this question, so what is the answer for this? Option C will be the answer. To solve this question, right, what are the things that we need to be convenient with? One, the radius relation in terms of the BCC arrangement and then FCC arrangement for the metallic type of lattice. So in case of BCC, root 3A is equal to body diagonal is equal to what? 4R. In case of FCC, phase diagonal, root 2A is equal to 4R. And the Z value for BCC will be 2, Z value for FCC will be 4. Other than that, no, it's just a ratio question. Clear, guys? We'll go to the next question. This is a theoretical question based on the defects. So look at the question. Which is incorrect statement? Means we have to, these kind of questions, right? It's like, packing multiple questions into one, because we have to read through the options one by one, then only we can conclude which is correct or which is incorrect. Look at this. What is the first option saying? Density decreases in case of crystals with Scotty defect. What is Scotty defect? It is the cations and anions, they will miss from the places in equal numbers. Scotty defect will be happening in case where the size of the ions is basically comparable. So as a result of the Scotty defect, right, what is going to happen? The density of the lattice will be what? Decreasing. So this is density decreases in case of Scotty defect is correct. Second, so we are looking for what, by the way, incorrect statement. NaCl is insulator in solid state. This is very important because NaCl, if it is in the molten state or in aqueous solution, right, it is a electrolyte. That is why it is able to act as a conductor in solution. But ionic compounds in solid state, they will be what? Insulators. So NaCl solid is insulator, that is correct. Silicon is semiconductor, that is also correct. Silver is a metal, that is a conductor. Quartz is piezoelectric crystal. What is piezoelectric crystal? If you have some materials, right, when you compress them, basically when you compressing means when you apply some mechanical, this is something that you will learn in physics also. If you apply some mechanical stress, then we will see that these substances will be able to produce the electric effect. That substances are called as what? Piezoelectric substance. Quartz is one of the examples of the piezoelectric crystal. Okay, so the second option is also what? Correct. We are looking for incorrect ones. Look at option C. What is option C saying? Frenkel defect is favored in those ionic compounds in which the size of cations and anions are almost equal. This is incorrect. Why? What is Frenkel defect? Frenkel defect is also called as what? Dislocation defect. What is Frenkel defect also called a dislocation defect? What happens? The smaller ions, be it the cations or anions, they will move away from their original lattice places and they will go and occupy the voids. The cations and anions, whichever is smaller, right, they will move out of their lattice positions and they will go and occupy the voids. This is what we call as the dislocation defect, and it happens when the cations and anions are too different in terms of sizes. Okay, so this is incorrect. So Frenkel defect is favored in which case when the sizes are too different. When the sizes of ions are too different, right? That is why this is also called as what? Dislocation defect. Okay. Now we got our answer, but this question, right, I'll tell you the fourth. Look at the option D. FeO 0.98 has non-stoichiometric metal deficiency defect. If you have metal deficiency defect, right, what will be the situation? The situation would have been that we will have iron in lesser proportion. So if we have a metal deficiency defect, the iron would have been in lesser proportion and not the oxygen. So the option D is also incorrect. So here what we are observing is if you compare this with FeO, right, we are in fact having excess metal. We are in fact having what? Excess metal. We are not having metal deficiency defect. So sometimes, right, I mean, in just like any other examination, NEET also, we do have questions coming like this where more than one option may be correct. Okay, in that case, what will be happening is whoever is taking whichever option, right, like somebody is taking option C or option D, both of them will be able to get marks. Okay, if there is like no answer for any question, any particular question means, then it will be like a bonus mark for everybody. Okay, so for this, right, guys, both C is incorrect and D is also incorrect because D is corresponding to what? It is corresponding to metal excess and not the metal deficiency. Okay, so we'll move on to the next question, guys. Look at this. This is the question that has come in the NEET paper 2 of 2016. We had the NEET conducted twice in that year. In calcium fluoride having a fluoride structure. Fluoride structure means what? So any substance having CaF2 structure is called as what? Fluoride structure. Okay. The coordination numbers of calcium 2 plus ion and F minus ion. So in a fluoride structure, right, each Ca2 plus will be surrounded by 8 fluoride ions. And each F minus ion will be surrounded by 4 Ca2 plus ions, because that is the balance, the charge balance ratio, right? For every 1 calcium, we'll have 2 fluorines overall, the composition. And the coordination number will be what? For every calcium 2 plus, it will be surrounded by 8 fluoride ions. And every F minus ion is surrounded by what? 4 Ca2 plus ions. So what will be the correct answer for this, guys? Option C. The coordination number of cations, calcium 2 plus ions is what? 8. What is the coordination number? the number of oppositely charged ions surrounding a particular cation or anion. That is what we call as the coordination number. So for the calcium 2 plus, what is the number of oppositely charged ions surrounding? 8 oppositely charged ions are surrounding. For the F minus, right, how many number of oppositely charged ions are surrounding? 4 of them are surrounding. Okay, we'll go to the next question, guys. So these kind of questions, right, this has come in the NEET paper 1 of 2016. This is a little bit numerically tedious problem, guys. So whenever we have a question like this, sometimes I have seen students, they will do the workout backwards also. Okay, so if they are asking you to find the edge length from the density measurement, right, they give the density and they ask the edge length, because remember in the density formula what will come for us? A cube will come. So finally we are going to get the A cube value, and then we have to take a cube root to get the A value. So this is this problem, right, in the entire solid state chapter. If at all we are getting a question like this, right, it will be the most numerically tedious problem. Why? Because first of all, from the given density measurement, we have to finally come to the A cube value. Then we have to take a cube root. See, taking a square root or taking an approximation of square root, most of us are comfortable. But taking a cube root, right, a lot of us might not feel the comfort. So I've seen, once you get the A cube value, right, what people do is they will work backwards. They will try and see which of the options on cubing approximately will give us the A cube value. Like that, some people will work it out. But we will see, what is the question? Lithium has a BCC structure. Density is what? 530 kg per meter cube. The atomic mass is what? 6.94 gram per mole. Calculate the edge length of the unit cell of lithium metal. So we need to find what here? We need to find the edge length. Avogadro number is given as what? 6.02 in 10 power 23. Okay. So it's a kind of straight question. Let us see what is the given information. What is the given information? It is forming BCC, means number of atoms per unit cell. Z is equal to what? 2. And density is given as what? 530 kg per meter cube. So we can convert this density into gram units. Why? Because atomic mass is in gram, right? So atomic mass we are taking it as what? 6.94 gram per mole. So density we want to convert this into gram per cc, means divide by 1000. Density in kg per meter cube divide by 1000 will give us what? Density value in gram per cc. Okay. Now Avogadro number is given 6.02 in 10 power 23. So what is the density formula? Z into atomic mass divided by Avogadro number into A cube. So from here A cube value will be what? We will take the other things the other side. A cube value will be equal to what? Z into atomic mass by Na into rho. Z is what? 2. Atomic mass is 6.94 divided by Avogadro number is what? 6.02 into 10 power 23 into rho. Density is what? 0.53. Finally the A cube value will be coming in what? Cc or centimeter cube. So A cube value, if you simplify it, right, we will get the value approximately as what? 43.5 into 10 power minus 24 centimeter cube. What is this? 43.5 into 10 power minus 24 centimeter cube. This is the value of A cube. So from here we have to get what is the value of A. So this is where I was talking about. If this is A cube, right, A we have to take it as what? Cube root of this. So cube root of this means the cube root of 10 power minus 24 is what? It is relatively easy. It is 10 power minus 8. Cube root of 10 power minus 24 is what? Because if you take a cube root, means this will be what? A will be cube root of 43.5 into 10 power minus 24 whole power 1 by 3. 10 power minus 24 whole power 1 by 3 means what? 10 power minus 8. Now cube root of 43.5. See, if you look at 3 cube is what? 27. And 4 cube is what? 64. Means it will be between 3 and 4. So the cube root, right, will be between 3 and 4. So it will not be between 2 and 3. It will not be between 4 and 5. It will be between 3 and 4. So we will see that it is a number between 3 and 4 into 10 power minus 8 centimeters. It will be number between 3 and 4 into 10 power minus 8 centimeters. Okay. So we can see that in terms of picometer, if you look at a picometer, right, what is a picometer? 10 power minus 10 centimeter is what? Picometer. So if you write it, we can write it as what? 10 square into 10 power minus 10 centimeter, 10 power minus 8. So this is like what? Between 300 to 400 picometer. So that is what I was talking about, the approximation. The value will be what? Between 300 to 400 picometer. So what is the answer going to be, guys? It will be what? 352 picometer. So this last step, right, is the little bit of tedious step. You will need to have some practice to solve these kind of questions. Okay, so we'll go to the next question, guys. Look at this one. This is another question that has come in the NEET paper 1 of 2016. This is the rather straightforward kind of question based on the ionic radius ratio. See, the type of ionic crystal will depend upon the cation to the anion radius ratio. What type of arrangement will be there for the ionic crystal will depend upon what? Cation to anion radius ratio. Okay, look at this question. The ionic radii of A plus and B minus are 0.98 into 10 power minus 10 meter and 1.81 into 10 power minus 10 meter. These are the ionic radius values. The coordination number of each ion in AB is, means we have to talk about what is the coordination number. Coordination number depends upon what? Coordination number depends upon what is the type of ionic lattice, right? First of all, if you take R plus by R minus ratio, what is R plus by R minus? 0.98 into 10 power minus 10 divided by 1.81 in 10 power minus 10. 10 power minus 10, 10 power minus 10 will be cancelled. This is somewhere around 0.541. Approximately, what is it? 0.541. See, if we are having exactly 0.9 by 1.8 means this is what? 0.5. Okay. So since the numerator is more than 0.9, it will be what? Little bit more than that. So 0.541. And we have the radius ratio table. So this is very important, guys. If the radius ratio is between 0.155 to 0.225, what is the geometry? Plane trigonal, and coordination number will be what? 3. Boron oxide is example. Between 0.225 to 0.414, tetrahedral zinc sulfide structure. Coordination number is what? 4. 0.414 to 0.732. This is our rock salt structure or NaCl structure, octahedral. Coordination number will be what? 6. Each cation is surrounded by 6 anions. Each anion is surrounded by 6 cations. If it is between 0.732 to 1, this is what? The cesium chloride structure, cubic structure, where the coordination number is going to be what? 8. In cesium chloride structure, if we look at the center of the cubic body, right, we will have one ion, cation or anion. All the corners, other type of ions will be there. In that case, what will be the coordination number? The coordination number is going to be 8. So here, so this is a straight question, guys. Once you get the radius ratio, means we have the answer ready. What is it? The radius ratio is 0.514. So where is it fitting? You can see where is it fitting? It is between 0.414 and 0.732, correct? So what will be the type of ionic structure it is having? Rock salt structure. So the coordination number is going to be what? 6. For NaCl structure or the rock salt structure, the coordination number is what? 6. Clear? So let's go to the next question. So these packing fraction, packing efficiency, void fraction, these kind of questions are quite common. I mean, not very recently, but at some point of time, these kind of questions used to come in multiple years. Look at this. It's a straight question, and already in our regular syllabus also we have the derivations for that. It is not like we are going to think and do the problem over here. Already in our regular practice itself, we would have had these values. Remember, for an simple cubic, what is the packing percentage? It will be what? 52.4%. For a BCC, what is it? 68%. The percentage of volume occupied by the atoms. For a FCC, what is it? It will be 74%. For a HCP also it will be same, 74%. Okay. So these values we have to remember. Now it's a straight question. If you are able to remember these values, means it's a straight question. What is it? The vacant space in BCC unit cell is, what is the answer? We are saying that the packing efficiency is 68%. Means the vacant is what? The remaining part. Remaining part is what? 100 minus 68, which is going to be what? 32%. Okay. So we have to remember these values, guys. The packing efficiency or the percentage of the volume occupied by the atoms. For a simple cubic, what is it? 52.4. BCC means what is it? 68. FCC or HCP means what is it? 74. That's why these two are called as what? The best cubic packing arrangement or the most efficient cubic packing arrangement. Okay. This is another theoretical question. The correct statement regarding the defects in crystalline solids. So mostly these kind of questions, right, they'll try to fix it on the Frenkel defect and Scotty defect. Anyway, look at the options, guys. So here what we need to find, we need to pick the correct statement. We have to pick the correct statement. Look at the option A. Frenkel defects decrease the density of crystalline solids. What are Frenkel defects? Frenkel defects are basically the dislocation defect. What they are called as Frenkel defect are also called as what? Dislocation defects. Why they are called as dislocation defects? Why? Because the cations or anions, which are very small, they move out of their lattice places and go and occupy the voids. As a result, right, the density of the solid will not change. So this is actually incorrect. The density will not be changing. So what is happening is basically from their lattice, designated lattice places, they will move out of them and go and occupy the voids. That's it. Second is what? Frenkel defect is also dislocation defect. Yes, correct. It is basically what? Dislocation defect. Why? The smaller size cations or anions, right, they will move out of their lattice places and go and occupy the voids. So this is the correct one. So we are looking for what? Correct statement, right? We are looking for the correct statement. So we can stop the question here itself. I mean, probably if you are doing the question in the examination, means you will stop it here. But since we are doing a revision sort of a thing or review of the paper, right, we look at the other two options also. Look at option C. What is option C? Frenkel defect is found in halides of alkaline metals. Now Frenkel defect, right, for the dislocation to happen, the size of the cations and anions must have a large difference. There should be a large difference between the size of the cations and anions. And this is generally possible in the ionic substances like zinc sulfide, AgCl, AgBr, AgI. This is not the case of alkaline metals. Okay. And Scotty defects have no effect on the density of crystalline solids. Scotty defect is basically the defect where equal number of cations and anions are missing from their lattice places. They completely miss out. And as a result, right, the density of the substance is going to be decreasing. So this is also incorrect. Scotty defect has an effect of the density. Scotty defect will be decreasing the density of the solid. Okay, what happens in Scotty defect? If you have the size of the cations and anions comparable. Okay, so we have comparable size of cations and anions, right? What happens? They will miss out of their places in equal proportion. That is what is the Scotty defect. Okay, so the correct answer for this is what? Option B. Look at this question. Sometimes we may get these kind of questions are like throwaway questions. So this is the question that has come in the year 2014. If A is the length of side of the cube, the distance between the body center and one corner atom. So in that cube, they're asking what is the distance between the body center and one corner of the atom. So what they're essentially asking, the distance from the body center to one corner. So if you look at the total body diagonal, right, what is the body diagonal length? What is the body diagonal length? Body diagonal is equal to what? Root 3a. Phase diagonal will be equal to what? So all these results we must remember. Phase diagonal will be equal to what? Root 2a. What is body diagonal means? One corner. Imagine the room that you are sitting in like a cube. So from one corner to exactly the opposite corner. If you can think about diagonal like this, right, that is what we call as the body diagonal. Body diagonal will be having the body center as the midpoint. So body diagonal is root 3a, means the distance we are asking here is what? Half of the body diagonal. Distance from the body center to one corner, which is going to be what? Root 3a by 2. So what is the answer for this? Option D, which is root 3a by 2. So if sometimes they will ask another question, what is the distance between the center of the face to a corner? Means it is going to be what? If you look at the distance from, if you take any face, right, take a face like this, the distance from one corner to another corner is what? The face diagonal root 2a. If they ask what is the distance from the face center to one corner, means it is going to be what? Half of root 2a, means it will be what? A by root 2. I mean, this is not related to the question, but I am just saying if you have a question like this, we need to be looking at that kind of an situation also. Okay, so we'll move on to the next question, guys. So sometimes when you have questions like this, right, I mean, you know, we need to make sure that we never go wrong in these kind of questions. Okay, so this is about what we have in part 1 of the past year NEET questions discussion of solid state, and we'll see again in the next part.